Hi, everyone. I'm Anil Seth. I'm a professor at the University of Utah. And I'm going to be telling you today about black hole demographics in low mass galaxies and stripped galaxy nuclei. This is work that has been done by my group over the last few years. In general, this work has all been focused on doing dynamical black hole mass measurements. And we do this by taking Hubble Space Telescope imaging, and we use that to get the stellar mass profiles of the galaxy. And we do this in a relatively sophisticated way, which includes accounting for the variations in the stellar mass to light ratios, and in some cases using results spectroscopy as well from Hubble. And then we use those mass models that we construct from the Hubble imaging to create dynamical models and predict the kinematics of the stars. And we compare that against adaptive optics observations with integral field spectra, like is shown here on the right for one galaxy, that tells us how much mass is needed, what the mass to light ratio of the stars is, as well as the black hole mass that's required to best satisfy the observations. And this is work that's been done by my former graduate student, Yu Nguyen, and my former postdoc, Mark Den Brock, who published 6 black hole mass measurements in nearby galaxies within 5 megaparsecs. These galaxies all have stellar masses between 1 and 7 times 10 to the 9 solar masses. So, more than an order of magnitude below the Milky Way's mass. And this is the first kind of black hole mass measurements in this mass range. And 2 of these have AGN activity, and they represent a complete sample of early type galaxies in this mass range within the local volume. And these are published in several papers. The result of this is that there's clear evidence for a black hole in 4 of the 5 nearest ellipticals, possibly all 5. There's a weaker detection in 1. And then that in turn suggests that there's a high occupation fraction down to around 10 to the 9 solar masses in galaxies. And that tends to support a low mass black hole seed formation scenario, in particular like population 3 stars. And the other result from this work is that we found the first dynamical detections of black holes below 1 million solar masses. And these are of the 6 galaxies, 5 of the 6 have black holes below 1 million solar masses, and 4 of those are relatively robust measurements. The other thing I wanted to mention was our work on black holes outside of galaxy nuclei in what we call ultra-compact dwarf galaxies. Ultra-compact dwarfs are really just the massive end of globular clusters. They're similar in size to globular clusters, but much more massive. And you can see an example of one on this image, M60UCD1, where in 2014, we found the first black hole outside a galaxy nucleus like this. And that was, it had a mass of 21 million solar masses in an object that was just over 100 million solar masses. So this is a really significant mass fraction. And what we think is going on here is that these are actually the stripped nuclei of galaxies. So our follow-up work has shown that in all of the most massive objects we've looked at, all the ones that are above 10 to the 7 solar masses, we found black holes, and 2 of those are shown here. This is work from my student Chris On. There's this 2 UCDs around M59. And we find that in all the cases, they make up a significant fraction of the mass of their kind of host UCD. And then we've also looked at lower mass UCDs and found upper limits on a couple, and then one detection, which Renuka Pichetti will talk about a little later. This work is interesting because these stripped nuclei we expect to be really common. In fact, in nearby clusters, we think that they're probably roughly as numerous as the present-day nuclei. So there's the same number of stripped nuclei and present-day nuclei. And that means that there'll be a lot of black holes in these objects. So something like up to about 1/3 of the black holes in the local universe may actually be in these stripped galaxies. And that has significant implications for tidal disruption event rates, LIGO and LISA rates, and just kind of our understanding of black hole demographics in general. So to conclude, we've dynamically detected black holes in sub-Milky Way mass galaxies and below 1 million solar masses. Their demographics can tell us something about the formation of massive black holes, and stripped galaxy nuclei do host black holes, and there seem to be a lot of these.